श्रीकांत सर ओके. तुमचा आवाज जरा बोलताय का तुम्ही?
हाँ ठीक ठीक ओके ओके. बाहर की है क्या जगह? Hello, good afternoon, all. Thank you for joining. On behalf of Shachi Engineering, I'm welcoming you all for joining this webinar uh, on optimization of industrial processes for with the help of spray drying technologies for various verticals of our like various product line like food, pharma, and chemical. On this segment, we are focusing on this webinar as of now. I think a lot of people are joining, so we'll just wait for another 5 minutes again, and then we can start. If you can just give me a thumbs up on or maybe any reactions in the chat if I'm able to, like I'm audible to you or video is clear, anything. Yeah. Okay. Thank you, Parthivji. Thank you. Okay. Okay, Vedant. Thank you. Thank you. Yeah, Mahayu. Yes. Thank you. Yeah. Thank you. Then. So I feel like voice is very much clear and video is also clear because afterwards I am going to share the screen also with the presentation because for today's webinar there little bit of change as compared to the last webinar series. Okay, so that I have made little bit of slide along with the pointers as well as the some process flow diagram, so that I'll show in the later. Just wait for 5 minutes of time and then we can start the discussions. Thank you. Hello, so good afternoon all. So I feel like now the everyone has joined and we are good to go. with the today's webinar on optimization processes with the help of spray drying technologies, specifically for food, pharmaceutical, and chemical segment. Okay, so I'm just sharing the screen with you all so that we can initiate our discussion and webinar. Okay, is my screen is visible to all of you? You just give me reactions on that part so that again I can start that. Okay, thank you, Mai. Yeah. So I'm just moving forward to start with. So today's webinar topic is uh, So today's webinar topic is our optimizing processes with spray drying and with a tailored application in food, pharma, and chemical production specifically. So for that, we have listed the three segment of industries where we have find out what kind of what you can say the punch point where we need to focus on to optimize the process in terms of to get the output, in terms of to get the efficiency, in terms of the how you can saving on OPEX part and the other critical applications on process point of view. So that will go through. So before going at what we are covering today is that the webinar objective I have already given. So optimization process for food application, process optimization for pharma application that we'll discuss, process optimization for chemical application, and Q&A session. And then afterwards, the bonus point of course, that is the one of the bonus point and declaration for all the participants. So before moving ahead, I'll just give you the brief about the Shachi Engineering, that what we do basically. So Shachi Engineering is a 26-year-old organization. We deals into the evaporation and drying technologies with the this 26 years of experience in this particular segment. So we have two business vertical. One is called as a Shachi process, where we do deals into the all the process equipment applications, kind of all dryers evaporation plants. So dryers consist of spray dryer, spin flash dryer, integrated fluidized bed dryer, flash dryers. So these all dryers are used for the specifically for the product application used into the food, pharma, dyes, pigment, and all other applications. Just you name the application, we are having our presence in that particular segment. Specific, same is with the evaporation plant. We do the evaporation plant with the product application like sodium sulfate, potassium sulfate, ammonium nitrate, that kind of application. That's evaporator, maybe a combination or maybe forced circulation, falling film. So all kind of evaporation plant. Another process, there is another equipment which we call as a spray coolers or spray congealing technology, what we are having with the Shachi Engineering, that we use into the completely fatty acid applications. So that is that we are planning to have separate webinar on spray cooler application specifically, because that is very vast and innovative application and having very interesting technology know-how about that. So that we'll discuss in separate webinar. The second vertical is about the your zero liquid discharge plant, means like what we called as its Shachi environment, where we do the complete end-to-end solution for the industrial wastewater segment for zero liquid discharge plants. So that we do the complete from ETP, UF, RO, and the zero liquid discharge plant by means of conventional technology, that is multi-effect evaporation plant followed by the post evaporation system, or with the latest technology innovation with the MVR based evaporation plant, mechanical vapor recompression also. Other things are also there, like other technologies, detergent powder plant, milk powder plant, and the allied systems also, and of course the self-cleaning evaporator technology. So this is the brief about the technology. Brief about bit about me. My name is Shrikant Datir, and I lead the sales here with the Shachi Engineering. I'm having 12 years of experience in the completely project sale for all kind of these process equipments which we are discussing today. So let's deep dive into the our today's discussion on specifically. Uh, just a minute, what I'm getting. Yeah. So now the screen is changed. I hope you are able to see my screen on the main, which I have highlighted the few points on the process point of view for optimizing the processes with spray drying technologies for tailor-made application in food industry segment specifically. So I would like to inform you all that when we specifically go for the spray drying application for food, so there are a few parameters which we need to take care very essentially, because when we say the food, it's a direct consumable part which comes to the human, so that point of view, so integrity of that particular product need to be maintained. Secondly, the purity of that particular need to be maintained. Third point is about the nutrition rate of that particular product need to be maintained, and the requirement on the particle point of view, that also need to be maintained. And to cover up all those things, that hygiene need to be maintained for the product application specifically. When we go for the any product application which deals into the which is having the food application, like milk powder, you can say flavor, fragrances, tea, coffee, or any other application which directly comes into the human consumption. So lot of this precaution need to be taken into the plant for specifically for the spray dryer, because spray dryer is the heart of all the processes. Maybe upstream processes, downstream processes, all processes will be there, but ultimately the spray dryer plant is the heart of that all overall plant assembly, because ultimately product will come out from your spray dryer plant. So upstream and downstream process may differs from customer to customer, from product to product, but ultimately spray dryer also remains the same, but technological configuration changes with respect to the product. Okay, so just we'll move to the pointers. So first thing, enhancing the powder quality, like product quality, we can say. So that what are the things contained in that? So consistent particle size, moisture content, and the flavor. Okay, that gives you the uniformity in particular. The applications like milk, flavors, fragrances, and the tea and coffee. So these things are need to be evaluated very specifically while designing the plant, because even with the application of particular application, like for the milk, or maybe for the flavor, or maybe for the coffee. So if you see, maybe these all are the food products, so why can't we go with the particular spray dryer plant? So the configuration of spray drying plant itself changes with application to application. So the spray dryer plant for the coffee application is not similar to the spray dryer plant for the milk powder application, or maybe the spray dryer plant which is suitable for maybe the which is on the configuration like flavors kind of product, which we are manufacturing the flavors on that particular plant. So you can't go with the coffee manufacturing on that particular product, because it's not about the application or maybe contamination point of view I'm talking, but it is still about the completely on the plant configuration itself changes. When we, because in this webinar, from the learnings from the last webinar we have done, we have included the few process flow diagram here for better understanding of all of you, so that what kind of processes we generally follow in the spray drying plant for such kind of application. Okay, so that is the most important from the powder quality point of view. So how this particle size and moisture content achieve, that is the separate part of discussion. That's what the configuration of the plant comes into the picture. So nutrition rate, that as I mentioned, that has to be maintained, because that is what the food, nutrition rate has to be maintained as per the requirement. Degradation should not be allowed, because that will reject complete batch of product if that kind of nutrition is not there. So that is huge loss to the customers. So that what we achieve in the spray dryer plant, maintaining proper process condition of the plant. So when you say the process condition, that is a lot of parameters. That may be your temperature profile, that may be your pressure range, that may be your airflow pattern. So all these things comes into the. Now the increasing efficiency, and when we say the increasing efficiency of any plants, so there are the points which we need to analyze, like what kind of drying time we should consider for the particular product, what kind of product yield we need to get, and how we can lower the OPEX particularly. So when we say the OPEX reduction, how we can do these particular, the heat recovery, we can do fuel consumption can be come down. So all those parameter will come into the energy saving part with interrelated to the efficiency. So in that pattern, we can reduce this complete operating cost of the spray dried plant, that we have implemented in few of our plant, where we can utilize the heat from our flue gases and reducing the OPEX straight away. Okay, that gives you the very huge impact on your operating cost. And reducing drying time again play a very important role, because the retention time in the dryer itself,
play a very critical role for the complete sizing of the plant as well as the drying cycle of the particular product. Okay, so that again depends on the particular what kind of application you are running the plant or what kind of food application you are having. You know, that is what the about the efficiency. Energy saving part I already covered in the particular part. Like, you know, heat recovery, that is one of the options. Second one, how you can manage your airflow patterns in the spray dryer plant. So that again gives you the what kind of pressure drop you are incurring, because pressure drop of your airflow pattern straight away linked to the your power consumption of your blowers. So that is what the main critical parameter which you need to analyze, because what we do in our plant, we do complete study of airflow patterns by means of CFD. So we have inbuilt CFD. We do all these parameters. You know, how the airflow pattern is in particular for particular application inside the chamber. What kind of pressure drops will arise? Various nodes on that particular air distribution. What kind of air distributor design will be? So that all parameters comes into the this energy saving part. And of course, the most important part is so enhance enhance hygiene. Just when I got a feedback that if you are not able to see the screen, let me stop the sharing and again reshare that. Now, are you able to see my screen? Okay, can someone give me no? Hello, Shubham, is my screen is visible?
Yes, sir. Yes, sir.
Yeah. Okay, fine. So what I was talking about the enhance the hygiene. So that is the most important part here for specifically in the food application, because what we say in the enhance the hygiene mean we need to do the complete automated CIP cleaning place for the or spray dry plant. So this automated CIP is provided with the complete dedicated tank with the heating and cooling arrangements, with the pumping, dedicated header, with the actuated wall at all the CIP zones. So CIP is managed by identifying the various CIP zone. So CIP zone can be, you know, at your top of the chamber, your bottom cone of the chamber, your top of the cyclone. Yeah, sometimes it goes with the back filter also. So you know, these are the main important things that how you should identify your CIP zones and where cleaning need to be done. And that has to be very automated, because human touch or human contamination is not allowed at all for food application specifically. Okay, so that kind of nozzle design, kind of airflow patterns, how kind of how will be the your flow and the spray pattern for the cleaning of that particular part, because CIP is needed for the from the three point of view. One is that as this is the food product, no external contamination is allowed. That is one part. Secondly, cleaning is needed in the part that because food is product is having the tendency to go for the microbiological growth, so that has to be addressed. That's why the CIP is needed. And if you wish to go for the product changeover, in that case, to avoid the cross contamination of the product, in that case you need to go for the CIP. So these are the main things where we generally go for this CIP, and customer also go for the CIP in this case. Uh, then minimizing the waste. So of course, this being a food application, each and every drop or each and every minor kg of product is the product for the customer, and that losses or even you know, anything need to be avoided. So how you can avoid the losses? So sometimes, you know, there is a particular particle size range, that is what the final product is. So to avoid that, main product you can get the particular you know, maybe a third stage of drying, or maybe below cyclone, maybe back filter. But sometimes it is like that, keep below cyclone and below back filter product, it is not usable for you. So how you can get that? So product what customer generally do or what we do, the technology aspect point of view, because that product need to be recycled back to your plant, so that it can be built up along with the particle size distribution and agglomeration purpose. And that agglomeration you can give at the various points in the spray dryer. That is again depend how the configuration of the plant and what kind of application you are operating. Because if it is got wrong, ultimately deposition will take place in that particular recycling point of view. So that is the most important way. Production flexibility, that as I mentioned, if it is there, so food product application, maybe tomato powder plant, maybe any extraction plant, fruit extraction plant. So for such kind of application, generally the single plant go on the working basis, and customer go on changing the flexibility. So that flexibility should be there in the plant point of view. Okay, when we are running the multiple product, and the plant changeability need to be there, and that has to be taken from day one when you go for the procurement of the spray dryer plant. It is not like that when you just procure the spray dryer from the tomato powder and you're operating for the herbal extract. It is not going to happen. So that you have to define at day one itself. This plant I'm going to run for this much of product. That may be possible, that may not be possible. That we inform you based on the analysis of what kind of product you are going to operate on that particular plant. And of course, the real-time monitoring, this is applicable for all kind of application. That may be food, that may be pharma, that may be chemical. So this is applicable for all this. So this kind of complete full-fledged automation along with the PLC SCADA, that has to be provided on one room, one screen. You get the complete analysis of the plant at your screen, and that what we provide the solution in that way. So that is as far as the food segment application. I'll just show you the one process flow diagram for the very typical and very critical food application, which goes on the textures of the food, which gives no, yeah. So I have changed the screen. I am on the screen of process flow diagram for this particular food industry segment. I hope you all are able to see it. Yeah, Shubham, just confirm me once if you are able to see my screen, so that all are able.
Yeah, actually your screen is visible now, Srikanth. Yeah.
Yeah. Okay. So I'm showing all of you. It's a completely three-stage integrated fluidized bed dryer plant. This is used for one of the food applications. Specifically, goes into the various kind of inner food application, building the texture of the food, given the quality, or maybe sometimes this kind of product goes into the cosmetic also, or sometimes this kind of application goes into as a pharma excipient also. So that is one of kind of application which we have given this plant. And this is first of a kind of plant which is given in India for such kind of application for all of you, and that what we feel proud in that particular application. So that's why I selected this particular process flow diagram to show you all that how the criticality and the integration of the plants play very important role while designing and to getting the particular output from the plant. So if you see, so I hope you all are able to see my cursor. So there are the multiple tanks before of the spray dry plant is given. So these tanks are nothing but the for the pre-slurry preparation kind of tank. The main preparation comes here with these two tanks with the agitators, with these pumps, and then again the intermediate tank is given, and then the main feed tank with the high pressure pump here given. This plant is given with the nozzle automation, and it's a high pressure nozzle. The operating pressure will go more than the 40 bar, and the design can be done around say 65 to 70 bar of application. And then the nozzle automation, the automation happens here. Drying take place inside this. Here the customer uses from the OPEX point of view. They have gone with the indirect fired hot air core generator you are seeing on the screen, and then this air is also taken into the plant, and the atmospheric air gets heated here with the help of coal fired hot air generator. And then this hot air enters into the top of air distributor, where air distribution happens as per the design airflow patterns, and the drying takes place inside the chamber, and then you get the final product at the outlet of your RAV. At this integrated fluidized bed dryer, and the second stage of drying take place here at the integrated stage, integrated fluidized bed dryer. And then the product again goes to the vibratic fluidized bed dryer, where the further stage of drying and cooling of the product take place. So you can see this plant is given with all the combination of the drying application, the first stage of drying, second stage of drying, third stage of drying, and the third stage itself implemented with the cooling. And the beauty of this plant is having the complete dehumidification system. So all the air inlets beyond maybe that may be a main air, that may be air to the your integrated fluidized bed dryer, or maybe a external vibrating fluidized bed dryer. All the air is given completely with the chiller radiator and steam radiators, completely with the for the to achieving that desired degree of dehumidification point of view. Okay, and the final product collected at the your outlet of VMPD, and the fines along with the hot air goes to the cyclone, where all fine collection is collected below cyclone as well as the back filter, and then fines from this cyclone is again recycled back to the your chamber for the further utilization of fines and further agglomeration to get the desired particular particle size. So that's what I was telling in the earlier slide. Okay, and the clean air exhausted to the atmosphere. And CIP system is completely provided here with complete tank, pump, piping, and particular header. You can see the particular CIP zones identified here, considering the nature of this application and the requirement of the CIP at particular location. And that's what the such kind of plant is required for particular application when we go for the spray drying procurement. Okay, so now we'll move forward to the next step. The next of our segment about the pharma segment. So process optimization with spreader technology for pharmaceutical industry. So what majority difference if you compare if you pharma and the food, it's not that, it's a very thin differentiation between the pharmaceutical and the food industry segment, because all those ultimately related to the human consumable products. So but the food is a little bit of tricky because the variety of application goes on the n number of variables. Same is applicable for the pharmaceutical, but in pharma, in place of nutrition point of view, rather than the focus is about the uniformity and the stability of the drug. Okay, and the purity also. These are the 3 points which majority play very key role while selecting the spray dryer plant for the pharmaceutical application. When I say the pharmaceutical application, there are the core applications of the spray dryer plant where the spray dryer can be used for the directly in APIs application, but there are very few and limited APIs application for which spray dryer can be implemented. But yes, there are the application like microcrystalline cellulose powder, MCCP. That is the one of the kind of pharma excipient. Another lot of pharma excipients can be go, and the ideal application for such kind of application is with the spray drying plant. So that's why and just to inform you all, the Shachi is known for in the market for the pharma excipient specifically, because we are leader for providing the spray dry plant for the pharma excipient, and we take proud to announce that we are executing India's largest MCCP spray dryer plant, and that we have already commissioned here in South for one of the German company. Okay, now if you see the critical parameter from the pharma industry point of view, it's a critical and precise particle size, because as just to inform you all, this spray dryer plant is designed to achieve this particular particle size, because this particle size is straight away go for the as a binders, as a additives to the main drugs. Okay, so all the tablets what we eat that is having this MCCP kind of drugs, or maybe another pharma excipient which go into the tablet manufacturing, and that uses a binder or maybe or additives. So that's why the particular particle size requirement is very important, and that's why our spray dryer is designed to achieve that particular point of view. Okay, so that gives you the particular particle size which is crucial for the drug absorption as well as the dosage accuracy. So that is one of the critical point which we can solve with our spray dryer. The drug stability, of course, maintaining API stability and extend the shelf life by controlling the moisture content. So when it comes to the drug stability, so there are 2 ways. Like one is if it is the excipient or maybe API. So what are the temperature conditions you are maintaining for this particular product, inlet and outlet condition, so that drug stability should be there, it should not get degraded. That is first one. Secondly, what kind of moisture content we are expecting from them, what is requirement from the end use point of view. So accordingly, that need to be adjusted, and the integration and level of degree of dryness need to be maintained. And if needed, the multiple stages also can be attached and can be put up into the plant configuration to achieve this particular. But the compatibility of that product and the flowability, all those things need to be maintained here. And accordingly, this drug stability point can be attained. Again, this is a very you can say the next step of the when the main drug get manufactured. In that point of view, the drug stability play the very critical role. The uniform party powder properties, consistent flowability and the solubility for easy tablet and capsule production. That's what I discuss. So flowability and the solubility or the dispersion, these are the main key area, because if somehow all of maybe few of you is already aware about this, because you might have using the spray dryer also. These are the very critical critical parameter when you go get the product output from the spray dryer, how you measure that the from the end use and the for your requirement point of view, dispersibility, what is dispersibility, what is LOD, what you get from the product characteristics. So that is the one of the part of your product properties, and for that the specific configuration, specific design of spray dryer is needed. So that is one thing. Purity and containment, of course, as this is a typical pharmaceutical application, there is no contamination allowed at all from any point of view. That may be a internal, that may be external. When I say the internal might be inner with the plant only, that may be from the plant itself, that may be from the microbiological growth point of view, that may be a from the external point of view, from the air itself. That's why the air filtration system plays very important role, because anyway for such kind of plant we are taking air from the atmosphere and heating it and putting into the plant. So whatever the air we are taking into the plant, that has to be very clear. That's why complete porous, fine and HEPA filtration, this 3 stage of filtration generally we provide. Even such of the cases, few of the cases on the hot air duct line also, we give the complete hot HEPA filtration also to ensure that there should not be any contamination from the outside. Okay. So this filtration, HEPA filtration, we have already shown you on the food point of the earlier process flow diagram, that complete HEPA filtration was there, and that what we have given. So that's what the lot of consideration need to be taken. The plant goes on building on such thing, ultimately goes on the capex as well as opex requirement point of view. But if it is the process requirement, it's a product requirement, it has to be there. So fifth point is about the solvent recovery. So reduced waste by recovering the solvent. This when it comes to solvent recovery, it is completely related to the API plant. So basically, this plant is completely closed loop operation, where your solvent with your final product is not water based solution, it's a solvent based solution with the methanol or maybe your IPA. So in that case, when you recover the product, this solvent becomes condensed in that particular position. So the solvent recovery, that is again and that solvent again can be put back into the process, so that your OPEX can be reduced accordingly. So that is another thing. So this is related to the closed loop spray drying plant. And then energy efficiency, that point like airflow and the heat recovery point of view, that is applicable for all 3 stages, where we can optimize the process from the OPEX point of view. And we are using also, because what we call as if you might are aware, like all of you probably aware about the recuperator systems, where we use onto the flue gas line, where the flue gas temperature probably high, and we can preheat the air which is going into the system, and then it can be put into the hot air generator, so that your fuel consumption straight away come down. So that these are the few points. Even you can go with the duct burners also, which we also manufacture, or in-house duct burner, where straight away fuel efficiency 12% in the reduction as compared to the all other burners. So that's kind of process plant design in the energy efficiency and saving point of view we do. Process safety condition as heat sensitive product. Of course, this is one of the critical parameter from the pharmaceutical application point of view. Process safety means like these pharmaceutical application are explosive in nature, because they are having their own ignition temperature, need to be dry on low temperatures, or maybe if temperature exceeded, there might be a possibility of fire, there might be a possibility of your explosion. So address that, the plant process condition need to be thoroughly established. It should not happen. Any variation is not allowed in this kind of particular plant. That is first point. Second, if any kind of altercation happens, like any incident of fire or maybe any incident of explosion, so there are several arrangements to address this issue. If explosion is there, primary stages you can go with the rupture disc. Above that, there might be a requirement of the explosion vent. You can go with the explosion vent. Above that, you can go with the explosion isolation system. Above that, you can go with that chemical isolation system. And more on that, you can go for the flameless venting system also. So these are the levels of the safeties which you can take into the plant configuration. But again, that need to be defined and conclude based on the requirement and the product, what you can say, the degree of product, how they are allowable, how they are having their explosion characteristics. So that again totally depends upon each and every product. In what we dry on the spray dryer plant is having their own KST and Pmax values. So that need to be identified, and based on that, this all system need to be designed. And based on that, we decide that which kind of parameter, which level of degree safety, which level of degree of safety we should go. So that is one of the most important point in the process safety, because that is very much costly also. For all of your information, the plant cost is altogether separate, but the safety parameters or maybe safety requirement, maybe a chemical isolation or maybe explosion vent, this is also the very high costly as far as the requirement point of view. Yes, in pharma, because that goes into the production, so scalability has to be there. So from lab production to the main production. So before any product or any company, what we are doing the business from last 26 years. So every company go for the pilot scale manufacturing, which we do also. From we have the range of our spray dryer plant from the 5 kg per hour water operation to the 10,000 kg per hour water operation capacity. So a lot of customer comes to us. We are having the pilot setup. They conduct the trial. They establish the product characteristics, particle size, the process condition, and then they go for the piloting plant first. They do the pilot at their facility, go for the pilot production, and over a period of time, they shift to the commercialization. Because by that time, they are very much sure, they are very much practical about the approach to the spray dryer plant. And then once they are sure to now they can handle the commercial operation, then they go for the commercial operation, this particular. So I'll just show you the one simple process flow for the spray dryer plant, which is related to the pharma excipient application. It is, you can see, this is what we have provided for the plenty of our customer for the pharma excipient application. So feed tank is implemented with the agitation, and the water funnel for the testing purpose. And the second with the screw pump is given here. Screw pump can feed slurry to the automation. Here the automation given is the rotary atomizer before the automation. And then automation take place here. Hot air from hot air generator enters at the air distributor. Here the air distributor design is altogether different. Airflow pattern is altogether different as compared to the earlier case. Now the drying take place inside the chamber. Hot air along with the product goes to the cyclone, where you collect your final product below the cyclone, and then again the series of cyclone. Now here's the specialization of Shachi, that we guarantee for such kind of application. It's not for the each and every application. Let me clarify here. This is for the kind of pharma excipient application where we have already established the solution, established the design, high efficiency cyclones, where we guarantee the outlet emission less than of 100 mg, or even in practical things we are getting the outlet emission less than 50 mg also. So that is what the practical experience we are going, and that's the series of cyclone work for such kind of application. Even though for other kind of pharmaceutical application, plant can go with the more complex in design, maybe a multi-stage of drying, that what I have shown you in earlier case, or maybe with the back filter, or maybe recycle arrangement, so that kind of all arrangements can be given with respect to the application, and that is varied for application to application. Even with the pollution control point of view also, that varies, because maybe a series of cyclone is there or may not be there. After cyclone, maybe back filter, maybe scrubber system, that I'll show you in the next track when we go for the chemical segment specifically. So I hope as of now we have covered two segments, food and pharma, and now I'm shifting to the chemical thing. But before that, I hope you all are clear and you're getting what are the processes which need to be focused on the optimization point of view on the spray dryer plant. Okay, So let me shift to the our third part of the discussion, that is optimization processes with the for the chemical industries. So as you see, I have for all the three cases, I have specifically marked about the particle size control specifically. Okay, so why I'm mentioning this point as the first for all the three things, because spray drying, when you go for the procurement, you should be very much clear on your mind what is application you are going to do, what are the quantum of you are going to do, and what are the market requirement of the particle size for your product. That you should know, because this is the most important thing for selecting particular kind of dryer, particular kind of automation system, particular kind of spreader configuration. So that's why this particle size is very much important for any of the cases. It's not related to these three application, but any of application when you're going with the spray drying thing, you should know about what kind of particle size requirement of yours. That has to be there. So that is first thing, the purity and the maintenance, as purity mentioned with the closed loop operation also. But to prevent that, the high standard of the fine chemicals generally, so contamination maintained, and the maintenance point of view, we need to take care of your inlet flows, the flow patterns, and the how you can manage your hot air generation part, because sometimes the contamination happens from that. A few of our customer facing that issue. They're in their existing plants for hot air generation. They have taken some plants from the other vendors, and the quality of workmanship also play very important role while such kind of inherent contamination. So what quality of building you're using, what kind of workmanship the customer, the your vendor is having, the design of your hot air generator, what kind of flame length you are maintaining, how much passes of your hot air generator is having. So these all things play very key role while to avoid the inherent contamination of foreign particle in your product application. So that's why these points are there, and that needs to be addressed for specifically for the chemical application side, because chemical application is, or the, when I say the chemical, is a vast arena which is having the n number of field in the kind of application, and that is some applications are abrasive, some application are corrosive, some is or the explosive in nature, and some are colorful. What you can say, the chemical is anything you can find in that particular thing. So that's why these all need to be taken care of in the purity and the maintenance point of view. And the third most important, the thermostability. Here you need to identify the thermostability of fluid. Generally, the chemical compounds are having the have an ability to sustain with the high temperature. So general operation for the all chemical applications is with the generally with the higher temperatures, maybe temperature more than 280 degrees Celsius, 320 degrees Celsius, 400 degrees Celsius at the inlet air temperature. That such kind of temperature thermal your chemical operate. But if some of the compound are heat sensitive, that prone to degradation, and that does not allow, and that doesn't preserve the integrity of the product, and ultimately product faces huge losses in that case. So temperature controls, maintaining the temperature control and the pressure control in this particular spray dryer plant, that gives you the very clear way forward for the thermal stability of your product in the chemical aspect point of view. Okay, and the powder properties, that is same like the earlier one also. So that dispersibility, hardness, and the bulk density, the particle size, all these are the key parameters in all those things. But the point number, serial number 0.5 is the key here, because chemical industry segment is not like the food, is not like the pharma. These production are generally going to bulk. So generally the capacity of the spray dryer plant for the chemical application is very huge. The bulk production happen, and that's why these plants are designed with the high drying rates so that to get the greater production capacities. So capacity range varies from. That's why I said like we have the capabilities to design the and supplied an erection and commission of the spray dryer plant of 5 kg per hour water operation to the 10,000 kg per hour water operation. And in this much of range, we have established all our plant in all this range. So you just have to name your application, what kind of dryers you want to go for, and we are having our presence in that particular segment. Okay. This automated monitoring. So complete plant need to have with the PLC SCADA based system. Again, from the automation point of view, we have gone one step ahead. We have given, like, when you say the PLC SCADA, all field instruments, like all transmitters give signal to the your PLC SCADA, you get the complete screen, all real time data. You can get what is the temperature going on, what is pressure going on, what is the airflow. But airflow measurements becomes the very critical in that part. So now we have introduced in our designs the anubar measurement for the airflow. That becomes very critical. And you can find that no spray dryer in the industry probably is there with the airflow measurements as of now. Generally blower capacities are defined, but actual during the operation, what kind of airflow are going on, you will not find it. So that's why that capability, that kind of integration, that kind of learning we go on, because that's what the specialty is Shachi, and that's what the Shachi is known for. Because if you find in a single place of the customer, we have the installation, like on a single customer, we are given the more than 40 plus plant of the spray dryer, and each plant is differs from each other. That's what the learning we take from each and every plant and go on developing and integrating the system. That's what we known for in the market. Safety assurance, as I explained, the degree of safety, what kind of degree of safety you need, that is again the main thing based on the completely characteristics of your chemical product. What is chemical compound, what is explosive range, what is KST value, what is Pmax. So when we decide that, you need to identify the degree of safety, what kind of degree of safety we should go. That we also suggest you, or we can also suggest you based on the data, what kind of degree you should go. But that has to be there, and that has to be there with the reputed things, because there are very few players in the market who give such kind of solution for the safety point of view. Okay, because this needs a certification. This kind of thing needs assurance, and that has to be provided with the regulatory authority, and there are few players who provide. Okay, and the flexible production, because chemical things are the when it's go on campaign basis, one campaign over, then second campaign come with a different product, a lot of things change over chemical formulation. So this plant is also go with the CIP. Sometimes this plant go with the manual CIP also, from the cleaning point of view, frequency point of view, because automated CIP need to be done very giving the all precaution, all the precondition, because pre-checks should be there for the automated CIP. You can't go with the CIP with the straight away with that. Whereas the manual CIP point of view, that again depends how your operating procedure are. If it is suits you, you can go with the manual. That also can be done, but that depends how the quantum of plant and the CIP effluent you are going to get generated. So because that is again the disposal cost for you. So that is what the thing and the plant should be flexible for the quick changeover. So that is from the chemical industry point of view. And this is the small typical process flow diagram for the chemical industry, where feed tank, feed pump is a screw pump, automation, and if you here the single cyclone can be given, below the product can be collected, and below that, out of that, here you can see the scrubber arrangement is given for the arresting the completely fines, which should not go to the atmosphere. Only clean air going to the atmosphere. So that the scrubber is acting as a pollution control equipment here. It is not like a scrubber is only the solution. You can go to the back filter, series of cyclone also. Depends upon the application completely, what kind of application we are going to run on this spray dryer. All of there I have shown you completely coal-fired, indirect fired hot air generators. But based on the fuel availability of site, we can go with the any kind of hot air generator. Coal-fired hot air generator will give you the maybe a low OPEX, because coal cost is low as compared to the other fuel. But the coal hot air generator probably needs a larger space, the lot of compliance from the pollution control point of view. Whereas the other hot air generator part, like your fuel gas base, or maybe your LPG, CNG, LDO, HSD, high-speed diesel, all these kind of things are the compact one and the clean one generally, and it is beside the plant only, so that can be mounted easily, low space. But the OPEX is high because of the fuel cost, as you all are aware. So I hope you all are clear about the what kind of segment, what kind of the things are there in this particular three segments, and what kind of consideration we need to take when we go for the operation of the particular spray dryer plant. Rather than I'll put in that word, when you go for the procurement, what kind of things are you need to take care. When you go for the process optimization, what kind of point we should take care, because that's pointers I have highlighted here. And finally, what kind of the final output you get from your spray dryer plant. So that is from for this session. And I hope you have all got all the ideas about the all those things, and we can start our interaction. If you have any queries, you can just put up your question in the Q&A session, and I'll just attend it one by one and go on discussing on the further for queries. And we can connect after this webinar also for one-to-one discussion if you have any queries on this particular point of view. Meanwhile, just you are putting in your queries into the Q&A session. There are bonus point, like, because we are executing this webinar series in a complete over a 12-month of period, and then you'll get the complete ebook free for the this complete webinar series, and the certification after completing of 3 webinars, and free pass to more webinars. Okay, so these are the advantages and the bonus point we generally give for our all participants. Okay, thank you so much for attending, and I'm just moving on to the Q&A session so that we can have one-to-one since. Okay. I'm just waiting for your query. I'm hoping like any queries you have mentioned. Any queries? If you have any queries, you can just put up your question. Just got one message here, some about the screw pump. Is screw pump suitable for feed operating at 58 bar peak pressure and 300 kg per hour? Who is Mr. Gautam Kumar? Yeah, Mr. Gautam Kumar, thank you. It's very nice question actually. See, screw pump is not suitable for operating at 58 bar, no, and with the pressure and the flow rate. Flow rate can be done with this, but pressure is not for the screw pump. Screw pump is the progressive gravity screw pump, and which does not allow this much of pressure to operate. For this much of pressure, if you want to achieve, you should go with the diaphragm pump. That may be generally for our high pressure applications. We generally use the imported pump from Hydra Cell, and that pump we use for all our application for when this much of operating range is needed. Yes. Okay, Arif. Yeah, Mr. Arif, you mentioned about the application in the temperature, bacteria, and recovery in microbiology. Okay. Yeah, Mr. Arif, I'll just give you the one example for this particular question. So one of the application what we do the spray drying is for the algae production. For spray drying plant, we have supplied in India, as well as we supplied the plant in abroad also for algae production, where this is nothing but the biomass. Over a period of time, when you go for the running and on the operating on the spray dryer plant, if some deposition happens at a particular place, and if plant stop by for some area, or maybe go for something over a period of time. So that gives you the suitable temperature condition when the plant goes top down to grow for the microbiome. So bacterial growth happens. And when the bacterial growth happens, that degrades that particular portion of product which is deposited at there. Okay. And when you again restart the product, probably you have done the CIP or may not, because you are running the same product. If you are not done the CIP, or if you have done the CIP also, if it is there, some of the point of is there, that will contaminate your whole product, because that goes into growth in that particular product line. It comes into the final product, and that straight away at a first instance, you will not find that your product is degrade. But if that kind of portion goes into your product, finally, your complete batch or maybe that particular product portion will get degrade completely. That's what the microbiological growth, what we can say in particular spray dryer contamination point of view. There are the application which comes into the pre-processing for the microbiological point of view for slurry preparation itself, because that kind of the culture is there. Okay. I hope I cleared your question. So third one, I got question from Alta Laboratories. We are told that spray dryer need 3 times more energy than RVD. It is true. 3 times. Yeah, Alta Laboratories. Okay, fine. So I'll put it in this way. Yes, a spray dryer is a continuous production system. Okay, and it needs a energy as compared it's a high energy as compared to RVD that is there, because but RVD's quantum is very low as compared to the spray dryer. So comparison with RVD to spray dryer, that becomes very difficult to compare with these two, because the operation philosophy for both the dryers itself is very different. Okay, rotary vacuum paddle dryer or maybe rotary vacuum dryer you're talking, but that altogether the different working philosophy, and this operation is having the different working philosophy. You can't compare, so you can't compare, say for example, this RVD can be compared with the paddle dryer or maybe a rotary dryer. That kind of dryer you can compare this RVD, yes, but not the completely spray dryer plant. Yes, spray dryer is the energy sensitive, but that's why the selection criteria for to go with the spray dryer depends upon the what kind of quantum you are going, what kind of initial solid you have, what is your product application. So that depends how you get your ROI and the product cost, not with the RF. I hope like that gives you the clarity. Can we recycle the air? Recycle the air. You are talking in terms of recycling the air of spray dryer or flue gas. What air? What recycle air you are talking about? I'm not getting clear view. But anyway, I presume that you are talking about the what is the flue gas coming out of the system that can be recycled. No, that cannot be recycled because that is the contaminated one. It's a hot air with the particular temperature, say temperature ranging from 75 to another 150 degrees Celsius based on the various application. That cannot be recycled, but that can be used for preheating to the main air. But that is again depend on, it's not happen for each and every application. That depends what kind of hot air, exhaust air is having the temperature of yours. So that is the main thing where we can recycle, means recycle the energy from that thing, but not the air itself. That becomes a closed loop. In that case, closed loop is operated with the recyclation of nitrogen, but not the hot air. The closed loop spray dryer plant, in closed loop spray dryer plant, it is possible because we use the nitrogen, where the nitrogen we go with the solvent get condensed, we can utilize solvent also, and the nitrogen in the system recycle back to the system again for heating and again put up into the spray dryer chamber. So that is the difference. Yeah. Any other points? Yes. Yeah, Mr. Gautam Kumar, you mentioned about the pressure. That I answer you on the diaphragm pump. There is another other pumps also. The plunger pumps also there, which you can go for the higher player. Triplex plunger pump generally, that you can go with the that much of pressure range you can operate. But reliability generally need to look up in that particular segment, how kind of reliability you want in that particular operation. Yeah. So application to application that vary. I hope now, I think all of us are there, and I'm waiting for the question another 2 minutes, or if you have the question on there, we are closing the today's webinar. But till time, if anyone is typing the question, just to inform you all, as Shachi Engineering started this webinar series, it's a knowledge booster for evaporation and drying technologies. So each and every month there will be a one webinar at the end of the month for this such kind of unique topic on the spray dryer, or maybe sprayed cooler, or maybe spin flash dryer, or maybe a ZLD, zero liquid discharge plant. So each and every kind of application, this webinar series will go on, and I hope this will give you the boost of knowledge, addition to your knowledge, for your application for the ongoing dryers, and I hope this will help you, so help you a lot. Yeah. So why there is one question again? So for Mr. Arif, yeah, why we need VABD again for drying after spray drying? Okay. So Mr. Arif, what happened? There are the certain applications where you need the particular size, particle size requirement, as well as the further agglomeration. Okay, so that's why the three-stage dryer is implemented for achieving that particular particle size. So first stage of drying happens into the chamber, where the drying takes place. Particle size is not formed. The second stage of drying happens into the integrated stage drying. Okay, so integrated stage drying, here the partial things are happen, drying is also happen, and size build up is also happen. Okay, and that size build up need to be evaluated and form the particular particle size. That's why the third stage of fluidized bed, vibratory fluidized bed dryer is provided externally with the heating and cooling arrangement, because you need the final product temperature as per your requirement, as well as you need the particular particle size distribution in overall. Okay, what, like say for example, you need a particle size around say 150 micron, almost 150 micron on that particular segment, say 100 to 150 micron, in this much of range, or maybe you degrade that what kind of grade my particle size should have. So when there is a criticality on this particular particle size, then you should go with the third stage of drying. And that is not applicable for all kind of application. There are certain specific application where third stage of drying are needed. I hope I cleared your question. Okay, so I feel I have attended all the questions, and let me thank you all for joining this webinar, and looking forward to for next webinar, and um, looking forward to you all for the next webinar also, to have with the new discussion on new topics with new insights. Thank you so much. Thank you. Yeah, we'll see you again, and wishing you all a very happy Diwali.